Just thought I'd give you a brief rundown on the 3-pin ultrasonic distance detector. This one has 5 volts ground and a signal pin. The signal pin is being set up for pin 7. And the 5 volts and the ground are being set up for 5 volts and ground respectively using the red and black wires. This particular sensor from Parallax with only 3 connectors is a little bit different than the 4-pin connector, which we'll take a look at in another video. Let's take a look at the simulation here and see how this can work. So when you hit Start Simulation, in order to be able to get the system to run, you want to click on the little green button. And that'll give you a range out to your target, and you can then drag that around using your mouse. Click on it left and just drag it around and you'll see the ranges. In order to be able to see those printed out, you want to bring up the code and take a look at the serial monitor output. And now you can see how it's being updated in real time. And as long as you're in the green zone, it'll be active. As soon as you leave it, it'll think it's ranging out to infinity, and so it prints out 132 inches. But here, when you're just touching, it makes it look like you're down to about an inch. So what happens is there's a little near-field blindness in here, and that gives you a kind of near-field, well, it's like holding your finger up too close to your nose. You can't really see your finger because your eye can't focus on it. Let's take a look at this code over here, which is kind of an interesting code. We'll stop the simulation for now. So what we've got here is the pin, and that's going to be pin 7 because, well, because that's where we plugged it in. And you can basically see that when we do the read ultrasonic distance, we specify the pin. You can have multiple sensors, and in fact, it's perfectly valid to do that. And then what we're doing in here is some simple conversions in order to make the sensor distance print out in inches and in how you say centimeters. Searching for the word. Sorry about that. So here we are doing the read. We've got this pin 7. We set up it for output. We toggle the signal low for clearing, delay for a couple of microseconds, and then set the pin on high for 10 microseconds. That emits a chirp. And then we set the pin to 0, so we're toggling the chirp down. And then we go to input mode so that we can read the time it takes to get a echo back. And then we return that travel time in microseconds. And then we have to convert from microseconds into distance based on the idea of how far a chirp can travel using standard temperature and pressure. We may like to adjust these things for different pressures and different temperatures, but in fact we're just going to accept some of the known constants that will allow us to convert for speed of propagation at sea level. So that's a brief rundown on the system. I hope you like my little demo. Talk to you later. Bye.